Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 50 is on the screen. Let's get started, please. Now, I'm introducing or reintroducing some of these concepts and skills that are from the past. Hopefully, you remember. But I do expect for you probably to do numbers 2 and 3 completely. Hopefully, you remember. I'll go over the rest. So let's get started, please. Copy and go. So, let me go over that warm-up just to make sure we're on the same page. I'm going to start off by completing the square. Now, I'm not going to get too deep into this. This is something that you should know, but I'm just trying to retrieve it from your long-term memory. And just to elaborate a little bit about completing the square, is as follows. If I had a square, do you agree that all sides measure the same? Yeah, that's what makes it a square. Therefore, if I had x plus 5 in this side, what does this side measure? X plus 5, because it's the same. Now, once I have x plus 5 and x plus 5 and I multiply them, I end up with a trinomial. Is that correct? But here I have only a binomial. I need to complete a trinomial in order to find a square, where it came from. So here goes the process. Let me erase what I have over here on this side, so like that you don't focus on that. So I need to find the third term. How do we do that, Mr. Q? You put plus. You're going to take the middle coefficient divided by 2 and square it. Divided by 2 and square it. Let me repeat that again. To complete the third term, you take the middle coefficient, which was 6, divided by 2 and square it. So let's see, what does that give us? X squared plus 6x. What is 6 divided by 2? 3. What is 3 squared? 9. Now we completed the trinomial. There it is. This is what we call completing the square. Now, hopefully, your Algebra 1 teachers, they taught you that, and it's starting to kind of like turning your noodle, yes? But here, what am I asking you to do at the end? Factor. 9 and 6. Factors of 9 that add up to 6. Everyone? 3 and 3. So my factors are x plus 3, x plus 3. What's another way of writing that? X plus 3 squared. Why squared? Because we just completed the square. Let's go. Let's go. Yes? Does that make sense? All right. So we're going to be practicing this because we're about to get into more of this when we come back from Thanksgiving break, hopefully. But I'm just giving you this ahead of time. Let's go to number 2. Number 2A, hopefully you remembered. I hammered this like 3 weeks in a row from the time that we got here to Algebra 2. So you remember what you got for 2A. What did you get for 2A? All right. I think Jalen's got it. Very good. Zoe's got it. Fabian's got it. But if you don't have it, ask Jaden. He's got it. Jaden's got it. All right, so here we go. In case you forgot, whenever we have a square root of a negative number, there's no such thing. We need to rewrite it. So this becomes square root of 4 times square root of negative 1. Is that correct? Yeah, so what is square root of 4? 2. What is square root of negative 1? The letter I for imaginary. Bah! Hopefully you remember. We did that like so many times on the warm-up. Yeah? All right. Let's go to part B. Part B, we have a fraction. Do you guys see the fraction? What's in the denominator? Square root. Can we have square roots in the denominator? No. According to the definition I gave you, we can only have integers. So to get rid of that square root, we do the following. Multiply it times itself. Whatever we do to the denominator, we do to the numerator. Therefore, on the numerator, 3 times that is 3 square root of 2. It basically stays the same. What is 2 times 2? 4. So I end up with square root of 4. And that's going to allow me to get rid of that square root of the denominator. So this is 3 square root of 2 over, what is square root of 4? 2. And we just got rid of the square root of the denominator. It's coming back. We're going to be using that pretty soon. Let's go to part C. For part C, when you can't find the square root of a number, try to find the 2 factors that make that number. What are my 2 factors of 20? 4 times 5. What is square root of 4? 2, and we're left with square root of 5. Let's go. All right? Now, I'm sure your neighbor knows how to factor this one the long way, which was by grouping, which what we did almost 2 months in a row. Show your neighbor your paper, see if they got that process down. Cold. Factoring by grouping, not the shortcut, by grouping. Okay, good. So I just thought I'd call someone. All right, to factor, first 2 steps. Is it a standard form? Yes. Is there a GCF? No. So, 16 and 10. Factors of 16 that add up to 10. 8 and 2, or 2 and 8. All right. So I rewrite the whole trinomial, bring down the first term, bring down the last term, and instead of writing 10x in the middle, what am I going to write? 2x and 8x. Is it coming back for some of you? And now we can actually factor by group and group. Yeah. So GCF for these 2 is x. We're left with x plus 2. GCF for these 2 is 8, and we're left with x plus 2. So what's the same here and here? X plus 2. And what's left over? X plus 8. These are coming back. I'm giving you practice because they're going to be part of the final by grouping. If you give me the factors and you don't do by grouping, it's wrong. All right. So far so good, yes? And the last one, number 4. Number 4, once again, if you were, let's see, was anybody here that was with me? Nope. If you were one of my Algebra 1 students, we covered this. We hammered inverse functions. If you haven't, if you weren't, hopefully your teacher did. So let me read you what it says. Look up. This symbol right here, let me read it. This says inverse. Inverse means this -1. Inverse function of x. Let me repeat that again. Inverse function of x. That's what it reads. Inverse function of x. All right. But right here I have f of x. So how can I find the inverse of this? I need to take a step back. What was it before it was f of x? Yeah, y equals 2x plus 6. Next, to do the inverse, I need now to solve for x. So tell me what to do to solve for x, to leave x by itself. To solve for x, I need to subtract 6 from each side. We end up with y minus 6 equals 2x. And then divide by 2, divide by 2. That leaves us with y minus 6 over 2 equals x. Is everybody up to right there? Yeah? Now, let me show you how to make this an inverse. Here it goes. This is the move. Ready? Here goes the move. Tell your neighbor what I just did to make it the inverse. What did I do to make it the inverse? Breno, what'd I do? Just switch the variables, the x for the y. Once you do that, now this is known as the inverse. Now, let me rewrite it in function notation. X minus 6 over 2 equals to the inverse of x. And that's how you get the inverse. Woo-wee. Let's go. Oh, yeah. During Thanksgiving break, you're going to be like staying up late doing your family math night and wake up in the morning. Turkey functions. Waking up with. Copy the agenda, please. Turkey functions. That's a good one, right? Oh, man. Warm up number 50. Transforming functions. Your home plate for tonight is only 2 problems. Only. All right. All right. Ready? So, only 2 problems. Last night's home play is that one. Go to Canvas, turn that in, please. Tonight's home play is this one. Make sure you take a picture after you turn in your home play. And next, get a Cornell note ready, please. When you set up your Cornell note, you turn the Cornell note over. Let me repeat that again. Set up a Cornell note, turn it over, and do 3 coordinate planes in the back from -10 to 10. I'll give you some time for that. Go. Get cracking. You ready? Here we go. Our objective for today can transform a function using different parameters. Now, I've introduced 2 of them. We started off slow. Today we're going to pick it up a little bit more and go a little bit deeper into this, okay? So tonight, your home play is going to be actually to write functions and graph functions that are already written in a transformed way, okay? So, with that said, what is our main concept still that we're on? Functions. By now you should know the definition, yes? All right, tell your neighbor your definition for functions. Definition for functions. All right, Ivan's got it. Very good, Ivan. Yeah. All right. Diego's got it. All right. All right. So you should have said relation and 1 input for exactly 1 output and such. And we're still with parameters. So write your utensils down. Look up to the screen really quick. So here's the general rule that we came up with. A general rule with 2 parameters, and it looks like this: g of x equals f of x minus h plus k. What are the 2 parameters? H and k. What does k do? It moves it up or down. Up if it's positive, down if it's negative. H moves it from what? Side to side. To the right if you substitute a positive number. To the left if you substitute a negative number. Okay? But this is where I want to make sure I get clear straight to you. Here it goes. Look up, please. What stays the same? What stays the same every time we transform? What stays the same is g of x, the equal sign, yes, the f for function, yes, the x, yes, and the minus. From there, where are the only 2 spots that we're going to be substituting? For h, or for k, or for both. Those are the only 2 we're doing right now. I'm not giving you the rest. I don't want it to be, here's one, I don't want you to be over here. So, are we there? Okay. So, with that said, where have we been? We talked about linears. K goes up or down. Talk about quadratics, side to side. Positive goes right, negative goes left. I gave you guys practice to do this one and that one. Yes? All right? So, in your Cornell notes, copy this, please. You're going to write general transformation rule. G of x equals f of x minus h, close parentheses, plus k. Then you're going to make a table with 3 columns. However, that table is titled parent function. Parent function. So copy that. For each row, look up really quick. Here for the linear, leave like 3 lines in space for all these rows. 3 lines for each. I'll give you some time to copy that. Copy and go. All right, let's do this. So, the general rule, g of x equals f of x minus h plus k, applies to any function. From this point forward, we're going to be working with different kinds. But today, I'm going to emphasize on these 3, linear, quadratic, and cubic. We've been working with linear from the beginning of the school year. Once we got to 2-variable equations, I introduced quadratic slightly about a month ago, and then yesterday reintroduced it. Today we're going now with cubics, okay? However, what makes them parent functions? That, look at it, all of them start with what? F of x, f of x, f of x. What else? That on the other side of f of x, you just have the x with its original form without any transformations. Is there anything else around the x here? No, nothing. Let's go to the quadratic. Original form, just with a squared, makes it a quadratic. Is there anything outside or around it? No, that's what stays a quadratic. Same thing for the cubic. Now, I do want to start with the linear. I'm going to zoom in here to this cell right here so you guys can see the graph. And I'm going to repeat a couple things that are going to be true for all parent functions, all parent functions. What does that mean again, parent functions? That it makes it its original form f of x, or that it's the originator. So kind of like, let's say, Jaden. Jaden started a group called the Cool Guys. Cool Jaden, right? And since he started the club, he's the originator of the club, so he would be a parent of that club. Does that make sense? Anybody that wants to copy what he's doing, it's no longer an originator, you're just a transform of whatever that started. Anyways, so with that said, let me zoom into that cell, look up. I'm going to go here where it says linear. So, here's my coordinate plane. A linear function always starts with 2 points. What 2 points? 0, 0, 0, 0, and 1, 1. Let me repeat that again. Any parent function always starts with 2 points. What are they? 0, 0, and 1, 1. Now, the linear is always symmetrical. For every 1 of the run, 1 of the rise. So therefore, 1, 1, what would be next? 2, 2, 3, 3, 4, 4. If I go the other way, -1, -1, -2, -2, and so on and so forth. So my linear function, parent function, looks like this. There it is. Have we been working with that? Yes. But that's the linear parent function. Okay? All right. So that's a graph. This is the form. And now we're going to translate using whatever information they give us. Let me zoom out. Here we go. Here goes the process. Ready? First things first. To write a transform function, we write our rule. What is our rule? G of x equals f of x minus h plus k. From there, we substitute whatever the translation they give us. So this one says what? Up 3. So you look at it and tell your neighbor, where am I going to substitute the 3 in? So I can ask Valente, where am I going to substitute the 3? All right, Valente, where am I going to substitute the 3? K is correct because that's for up and down. And this one is going what? Up. So once I have that, I'm going to rewrite this. G of x equals f of x. I no longer need the h because we didn't move it to side, so side. And then plus 3. And that's how you rewrite your function already transformed. So what's the process? You write your general rule, then you substitute your values, rewrite, and then that's your end function. From 1 to 5, how comfortable are you up to right there? Yeah, 5, 5, 5, 4, okay. All right, let's go to the next one. Let's go to quadratic. Let me zoom in. Now, before I graph it, tell your neighbor the first 2 points we're going to plot for quadratic functions. Tell your neighbor so I can ask Valente, what are the first 2 points we're going to graph? Valente, pass someone. Fredo, what are the first 2 points? 0, 0. 1, 1. So let me make sure that we're getting that idea. Look at this linear. What were the first 2 points? 0, 0, 1, 1. Let me go to the quadratic. What are my first 2 points? 0, 0, 1, 1. What I'm trying to convey here is that all parent functions have 2 points in common. Tell your neighbor what they are. 0, 0, and 1, 1. All right. However, this ends up being a parabola that looks like this, which means I need a negative 1, 1, and I need a 2, 4, negative 2, 4. That's our parent function for f of x equals x squared. This is known as a what? A quadratic. All right. What does it look like? F of x equals x squared, and now we're going to do a transformation. All right, so let me zoom out. Here we go. We're going to translate 2 steps to the right and 4 steps down for that quadratic. So I start with my rule. Here it goes. What is my rule? G of x equals f of x minus h, close parentheses. However, look up, this is a quadratic, which means it has an exponent of what? 2. That goes right there, plus k. All right, so with that said, it says translate 2 steps right and 4 steps down. Think about it. Where am I going to substitute that? Tell your neighbor, please. So like that, Fredo can pass it to someone. All right, Fredo, go. Diego. Rosas. Change the h to 2 and changes the k to 4, negative 4. Okay? So let's see. Right 2 steps, so it's a positive 2. That is correct. 4 steps down, so it's a negative, yes. And then we just rewrite this. G of x equals f of x minus 2 squared minus 4. Hands, have you got that? All right. I think we got it, yeah? All right, let's do, let's go to the cubic and then we'll do some practice with this. Here we go. Let's go to the cubic. Let me zoom into that cell. Now, tell your neighbor the first 2 points you're going to graph to the parent cubic function. Everyone, 0, 0, and 1, 1. That is correct. All parent functions have those 2. However, the cubic function looks like this. How do we get this curve all the way up here? Well, this is 0, 0, 1, 1. Check this out. 2, 8. Because 2 cubed is 8. Then negative 1, negative 1, negative 2, negative 8. That's my cubic function. What does it look like in function notation? F of x equals x cubed. And now we just need to write our translation according to what they tell us. Here we go. So we write our form, g of x equals f of x minus h, but this time instead of squared, it's what? Cubed plus k. All right, so substitute the values, rewrite it in transform notation, and tell your neighbor what you got so like that deal can pass to someone. All right, show your neighbor, please, what you get for your transform function, What you get? Do you ever pass someone? Joel. G of x plus 3 cubed. What else? Plus 2. Hands if you got that. That is correct. Why? It says here 3 steps left. That means it's negative 3, and negative times a negative is a positive. And then 2 steps up, and that's our rule right there. Okay? Now, here's what I want to convey. Look up, please. What is the same on all of these when you get started with your general rule? All of them have g of x equals f of x minus g of x equals f of x minus g of x equals f of x minus. The only thing, this one's linear, this one is quadratic, and this one is cubic. That stays the same. All right? From 1 to 5, I'll come to you with this. Yeah, we got this. 5, 5 fourths. Okay. So, give me a second. All right. Next, turn your paper over. Next to that first coordinate plane, I want you to write example Star Wars Q, and it reads, graph the function f of x equals x cubed. We're going to graph it without a table. And then we're going to write a new function after translating the parent function 3 steps right and 6 steps down. Copy that really quick. I'll give you some time to copy. Then we're going to get started together. About 30 seconds, yeah? So, let's graph this together. So, neighbor, the first 2 points you're going to plot. Yeah. By now you should know it's 0, 0, and 1, 1. 0, 0, 1, 1. Oh. 0, 0, 1, 1. Okay. Now how do I get the other ones, Mr. Q? Well, let's go to the next value. What is the next value of x? 2. What is 2 cubed? 8, because it's 2 times 2 is 4 times 2, that's 8. So we go to 8. All right, so I already have 0, 1, and 2. Now I'm going to go the other way. 0, negative 1. What is negative 1 cubed? Negative 1 times negative 1 is 1, times negative 1 is negative 1. What is negative 2 cubed? Negative 2 times negative 2 is 4, times negative 2, that's negative 8. So this is our parent function, or parent cubic function. There it is. We're going to label that f of x. All right? So, we're done graphing the parent function. What does it say then? Then write a new function after translating. What does that mean, translating? Moving that one. Where are we going to move it? 3 steps right, 6 steps down. So, here we go. I'm going to start with this one, this point right here. 3 steps right, 6 steps down. 1, 2, 3, 1, 2, 3, 4, 5, 6. Next, this point right here. 1, 2, 3, 1, 2, 3, 4, 5, 6. And check this out. I don't even have to count the other points because I know they are diagonal from here. See what I did? Yeah? And my last point, this one. 1, 2, 3, 1, 2, 3, 4, 5, 6. And tell your neighbor what you're going to label this one. Yes? G of x, because that's no longer the original. This is the transform. So, let's write our new transform equation. This is the parent function equation. There it is. So, we need to write a transform equation. So, who went last? Was it Diego? Yeah? No? Who went last? Joel, pass him one. Fredo? All right. Give us the general rule. G of x equals q plus k. Yes? So you write your rule first, and then you substitute the values. Pass someone? Valente. What do I substitute? Give me at least one number, and where do you want me to substitute it? There's only 2, 3 or 6. 3 steps right or 6 steps down. Which one do you want me to substitute and where? All right, share with your neighbor really quick before Valente gives me his answer. Share with your neighbor where you're going to substitute and what. All right, Valente, go. -6 for k. 6 steps down. Yes, that is correct. Pass someone. Ivan. H for what? 3 for 3. 6 to the right, 3 to the right, that is correct. So we write g of x equals f of x minus 3 cubed minus 6, and this is our new function. Woo-wee! From 1 to 5, how comfortable are you graphing and rewriting our new function? 5 fours, okay? That's a nice home plate. Yes? Your final answer is your transformed function. Yeah? All right. So, before you put your stuff away, I just sent you this screen. I want you to, on the screen, plot me the first 2 points of that function. And then see if you remember the other points that need to be graphed. Everyone, what are my first 2 points? 0, 0, 1, 1. And then the other one says 2, 4, negative 1, 1, and negative 2, 4. And it should look like that, my parent function. And then from there, you know what to do with the rest. Yes? All right, we'll stop right there. All right, so the whole thing, from 1 to 5, how comfortable are you so far with H and K and graphing and writing? Yeah, 5, 5, 5, force. Okay, we'll stop right there. Once again, reminder, if you need to come and get some tutoring after school today, be there or be elsewhere, yes? And remember, it's free. Free. My goodness. I'll stop the video right there. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.